All right, we are in Chapter 3, Section 3, called Rate of Change and Slope. So as always, I'll just start off with the little tutorial that I do for the front screen here. So this is what your homework will look like when you open it, with the exception of two pieces. The first one is, I do not have a due date on my screen. You will have one on yours. It does not give me a due date on the teacher preview. And attempts, you will always see the number of attempts that you are on. So I'm on number 1 of unlimited attempts. Unlimited attempts means I can submit this as many times as I would like. So we'll talk about submitting in just a moment. But submitting an assignment does not lock out the assignment. It actually tells the teacher what you've been working on, how many you've completed, and it also stops the system from locking you out of your other assignments, which we'll also talk about in just a moment. But you can submit that assignment as many times as you would like. This particular assignment has 10 questions on it, which is the maximum. So there's going to be anywhere from 1 to 10 questions. Grading policy is always best score, so whichever attempt is your best one is the one you keep. And partial credit is enabled, meaning if you answer 1 of 10 questions, you get credit for your 1 question. This is just a reminder about submitting your work. So once you've start your homework, you must finish it before you can work on anything else. So this is what I was talking about. Once we click start here, on your screen, this is the second piece you won't see on my screen, but on your screen you will see a submit assignment button in the bottom right corner. So once we've clicked start here, no matter what, when we want to leave this screen, we need to click that submit assignment button. Otherwise, it will lock you out of every other assignment. It won't let you work on anything else. So once you want to leave, even if you've only done 1 question of 10, it's okay. Click the submit button and you just go back in and you work on the rest on a second attempt or a third attempt or a fourth attempt or however many it takes you to finish. Okay? On the side here, you will always see these 3 tools, and you may also have a calculator from time to time. So this first one is explanation. It's telling you you're going to lose your question attempt because it's going to explain this exact problem that we're looking at. So it's going to give us the solution and the answer to this exact problem. So it's not going to give you the answer and then have you come type it in. But it is a very neat feature because if you look at example, and maybe you completely understand this example, which is just a pop-up that opens up, and it will walk you through a very similar problem here and how to type in the answers, how to, go through all the pieces. And maybe you completely understand the example, but for whatever reason you don't understand this problem that is presented to you, you can click on explanation and have that explained to you. You'll just have to come in on another attempt to get credit for that problem. And then you can click on explanation again and again and again. It'll keep giving you example again and again and again, and it'll start giving you new examples. Message is just so that you can message your teacher. It attaches this problem to the email that it's going to send out, and we know exactly where to go to help you there. All right, let's go ahead and get started. So for rate of change and slope, what we want to do for rate of change and or slope is make sure that there's some kind of consistent change from one piece to the next. So when we're looking at a train travels from city A to city B, the table below shows the distance and the amount of time it takes to travel on the train. So what we want to do is make sure that it's a consistent amount of time for the distance we're traveling. And that will let us know if it has an actual rate of change that we can figure out. So we have 2 options here. We either say the train does not always go the same distance each minute, or the train appears to go the same distance each minute, and we can predict the amount of time it will travel in 54 kilometers. So when we're looking at this, and I'm going to go ahead and write it over here, 12 and 2, 24 and 4, 35 and 7. So for this one, what I want to do is compare and say, for 2 minutes, how far did the train travel? So it traveled 12 kilometers. So if I reduce this and I say, well, that can divide by 2, and it'll get 6, and I can divide 2 by 2, and I get 1. So what this means is for every minute, the train travels 6 kilometers. So now I know how fast it's going. I just need to make sure that this is consistent. It's 6 kilometers per minute. So I want to do the same thing with with each of the rest. I want to go 24 divided by 4 and make sure that I do get 6. Because 6 kilometers over 1 minute can be reduced down to just 6 kilometers per minute, or just 6 if you're thinking of just the number. So this one does work out. And then I want to do the same thing with the last one, 35 divided by 7. Well, this doesn't give me 6. This gives me 5. So, the train must have slowed down a little. It's only going 5 kilometers there. So this would be a no. The train does not always go the same distance in each minute, so I can't accurately predict how far it'll go in 54 kilometers. Or accurately predict how long it'll take, because it changed its speed. If we look at the second one here, there we go. So we have Karen is deciding how many people to take to the movies. The table below shows the cost for different size groups of people. So now I have, for 2 people, it's $16. For 4 people, it's $32. And for 8 people, it's $64. So now I want to figure out how much it is per person. So I'm going to go 16 divided by 2, and that's 8. So for this first group, it was $8 per person. Now if I go 32 divided by 4, I get 8 again, so that's good. And then 64 divided by 8, I also get 8. So each time it costs $8 per person. That's just me reducing it down, and it would be $8 per one person, but I don't need to put the over 1 on there when I type this in. So this is my change. Every single time I add a person, it's another $8. So we are going to have a consistent here. It appears to be the same for each person. And now it says, what is the cost for 9 people? Well, if I have 9 people and I know it costs $8 per person, I just need to multiply this, right? 9 people times 8 gives me $72. So this will be 72. And they already have the dollar sign there, so you don't need to try to type that in. It's already there for you. All right, perfect. Let's go ahead and keep moving here. Boom. All right, so this one says find the distance between point I and point J. So when you have points that are directly above and below, or if they're beside each other, so left to right, all we have to do is count the distance. This one is a pretty simple concept where we're just saying, okay, how far apart are they? So this one I'd go 1, 2, 3, 4, 5, 6, 7. So their distance is 7. It's not -7, it's not +7. I'm just saying the distance between them is 7 units, because there's those boxes and we call those units. Same thing if they were, sideways or beside each other. So we would just count from one point to the other how many boxes or how many units they are. And don't go like this. Don't go 1, 2, 3. You have to go from here to here is 1, and then 2, and then 3. So the actual jump is the count, okay? So just be careful about that when you're counting them. Click check, and we should be good to go. Uh-oh, unless it's freezing. Don't freeze. All right, looks like I'm going to have to click on the assignment again really quick just to reopen it. So we're not going to have that same example there, but that would have been a green check mark there for sure. It just froze on me. So let me go back in here. And I'm going to go ahead and go to number 3, because that's where we would have been moving here. So we just don't get to see our check marks here. On your screen, as long as you've done this on your account, it will save it. On the teacher preview, it always opens it brand new for me. So, all right, we're going to take a look at positive, negative, and neutral slopes and undefined slopes. So if you remember, we did this at one point during the semester here. This was, I think, during one of the first few classes we did. A really cute way to remember slopes is if we think of slope man, like this. So we draw a face, and we're going to give him an eyebrow here with a plus sign for an eyeball. And that's because this is a positive slope. Positive slope. So it's kind of a silly way to remember this, and it's always going up from left to right. So it's kind of in an upward motion there, right? And if that helps, you can put like a little arrow on his eyebrow so that you know it's going up in that direction. And then we're going to give him another eyebrow that's going down, And this is he's winking with this eye, or blinking, I guess. So this is a negative slope. Negative slope. And then we have his nose, which is just a line with a U on the bottom. Well, this represents undefined. Undefined. I almost forgot the E there. Undefined slope. And that's because it's straight up and down. It's a straight vertical line. So we don't actually have a slope on that one. We call that undefined when it's literally going straight up and down. And then we have his mouth, which is just a flat line there. And we give him some dimples here. And that represents a 0 slope. And that's a flat line. So there's no slope at all. You can think of like the floor, a typical floor that it's not going up, it's not going down. It's just flat, straight across. So there's no slope on it. So we're just going to go through and match. So this looks just like his mouth with a flat line here. So that would be a 0 slope. This is going up from left to right, which is like his first eyebrow here with the plus sign. So that's positive. This is a vertical line going straight up and down. So we call that undefined. And then we're going down from left to right, which is kind of like his eyebrow here. It's a little bit steeper, but same idea. So this one's negative. All right. Next. So we're going to erase our little slope man here. Okay. So this one, when we want to find the slope of a line and then we're given the graph, you can do this visually on the graph. You can go from one point to the other, and we want to think of rise over run. Because remember, that is always our basic way to remember slope. We have rise, which is our change in y's, over run, which is our change in our x's. So rise, if I want to go up to kind of the same level as this one here, I'm going to go 1, 2, 3. And now I'm on the same line as this guy here. So I went up 3. And then I'm going to go to the right 1, 2, 3, 4, 5 to land on that same point there. So it's positive 3. I went up 3, and it's positive 5 because I went right 3. So be careful about positives and negatives when you're doing this. Up is positive, down is negative. Right is positive, left is negative. So you just want to be careful about that. And you can type this in. You can either hit the little fraction bar or you can hit the backslash on your keyboard, and it will also put the fraction bar in there for you. Make sure these are reduced. So if you do have a fraction or a number, numerator and denominator that can both be reduced or divided by the same number, you want to make sure you do that first. 3 and 5 are both prime, so they are good to go. All right. So again, visually, pretty easy to do. We're just counting rise over run. If we have points, now we have to use the slope formula, which if you click on explanation, if you don't know these, they should give you this background really quick so that you know, oh, okay, here's my actual slope formula. So instead of just rise, because I don't visually see this, I can go y2 minus y1 over x2 minus x1. And what these y2 and x2 mean, and I'm going to go m equals because m is the letter we use for slope. But what y2 and y1, x2 and x1, what these 1s and 2s mean is it has to do with the points. So remember, we always have x and y like this. Well, now we have 2 of them, and we don't want to get confused on which one we're talking about. So we have x1 and y1, which just means it's from point 1. And x2 and y2, which means that they are from point 2. That is all it means. It's just a labeling system. So that we can very quickly say, okay, well, what's y2? It's going to be, the y coordinate for my second point. That's what that means. So we can plug these in so that we can figure out what the slope is when we're given points. You can also graph it and then do some counting there, but you're actually doing the same thing either way. We're going to figure out the change in y, which would be the same idea as counting it, and then we're going to figure out the change in x. So with this one, if I write these down here, I have 2, 5, 8, and negative 4. So now I can see if I want y2, I can go y2 and go right underneath. It's going to be negative 4. Minus is part of the equation here. Don't change that. And then y1 is going to be 5. Why did it undo that? 5. And now I'm going to go to the bottom. My denominator, I have x2. So here's my x-coordinate for my second point, minus x1, which is 2 in this case. So now I just need to solve these. -4 minus 5, that's -9. 8 minus 2, that's 6. So this is an example that needs to be reduced. We don't want to type it in -9/6 because both of these can divide by 3. So we need to reduce it first. And Alex would have warned me about that if I try to type this in. And I can even show you the warning that it'll give in just a second. So -9 divided by 3 is -3. 6 divided by 3 is 2. So before I type in that correct answer, well, they're both correct. I don't want to say correct answer, the reduced answer. So 9/6. I'm just going to show you when I try to do this one, it's going to give me a warning and say your answer is correct. However, the fraction can be simplified. So it actually even gave me the point for it already. In some situations, it's going to say that's not reduced. Make sure you reduce it before it'll even give you a point for it. So it just kind of depends on where you are within the system here on how much it's expecting you and how far it's expecting you to go. It didn't say completely simplified, so that's probably why it's not marking us wrong on it. All right. So we are going to do this a couple more times here to show there's a way to identify that 0 and that undefined slopes when you're looking at the equation here. So remember, slope equals y2 minus y1. Losing my mind here while I'm talking. All right. And we have x1, comma, y1. And x2, comma, y2. Okay, so let's go ahead and look at this first one. We have -6 and 3. We have -6 and -7. So if we start plugging this in, we have -7 for my y2. And then we're going to say minus y1 over x2 minus -6. Because it's x1 is -6. And this minus is a part of the equation. So we need to make sure they both go in there. It's minus negative. Well, that's a double negative. That's just the same thing as multiplying two negatives. So this actually becomes a plus whenever you hear a double negative like that, minus negative. So this is going to equal -10, -7 minus 3 is -10, over -6 plus 6. Well, those are opposites. I subtract and I get 0. We can't divide by 0. Remember, the bottom of a fraction, the denominator, tells us how many points there are available. Or not points, but how many pieces are available. I'll say it that way. Well, in this case, I have -10 of 0 pieces. Well, that doesn't make any sense. How do I have -10 if there weren't any pieces to begin with? So once we have 0 on the bottom, we immediately say this is undefined. That is a vertical line going straight up and down. And that's exactly what it means. It means we're dividing by 0. That's why we say it's undefined. So now if we look at the second one here, I'm just going to stack these. So this, just so I don't have to rewrite everything. So we're kind of ignoring this one for a minute, just so that I can kind of reuse these. So now we have y2, that's -3, and y1 is also -3, so it's minus negative again. X2 is 8, and x1 is -2. So it's minus negative again, like that. So minus negative, that becomes a plus. Minus negative, that becomes a plus. Well, -3 plus 3, those are opposites, so they become 0. 8 plus 2 is 10. This is a legitimate answer. This is not undefined. 0 divided by anything is just 0. This just means I had 10 pieces and now I have 0 of them left. You know, maybe you ordered a pizza and there were 10 pieces on that pizza and everybody ate them. They're gone. That's a legitimate problem. But in this one, this is saying that, I started with 0 pieces. Maybe we can even talk about pizza. I started with 0 pieces of pizza and now I'm missing 10 of them. There's -10. Well, that doesn't make any sense. I started with 0. So how am I missing anything? So that's just the difference between 0 in the denominator and 0 in the numerator. So this is a 0 slope. So we just type in 0 here. Check. All right. Trucking right along here. Okay, so this one's a little bit different. So we still have our same equation here, x2 minus x1, and we still have our pieces here, x2 and y2. But now it's saying the points 5, 9, and 7 r lie on the line with a slope -5. Find the missing coordinate r. So now we're given the slope. Remember, that's what m is just the variable we use for slope. And we're missing one of the coordinates. But we still go through and we plug it in just the same. But now we're going to have it equaling a number already. So we have 7 and we have r like this. So I have m, remember that's my slope. So -5 equals y2, which is r, minus y1, which is 9, and then x2, which is 7, minus x1, which is 5. So now I'm going to reduce this bottom one by saying 7 minus 5 is 2. And when the entire side is being divided by a number, I want to multiply by that number so that I can kind of get rid of the fraction issue here. So 2 times -5 is -10. And then 2 divided by 2 on this side cancels out. So I just have r minus 9. So that's why we want to multiply by whatever that denominator is on both sides, because it eliminates the fraction on the side that it's on. And now all I have to do is say plus 9, because I want to eliminate these guys, and r equals -1. -10 plus 9 is -1. So r has to be -1 in order for -5 to be the correct slope. So that's what we need it to be. All right, a couple more of these guys and we will be all done. Okay, so when we're looking at functions and we want to state whether it is linear, we want to check for a pattern. And I'm going to show you on here because I think it's a little easier to actually look at this. Whoops, sorry, it keeps reloading. So this isn't the exact question here. This is a different example, but we can still take a look at this. So if we have coordinates here, we want to look at x, y. And if you notice, they drew this x, y table because that first one doesn't give us the x, y table. It just gave it to us in coordinates. So they drew the x, y table and they're comparing. If I increase by the same rate on the x column, do I increase by the exact same rate on the y column? And when I say that, I don't mean that we're increasing by 2's, so we have to increase by 2's on this side. What I mean is this side always increases by 2's, and this side always increases by -3's. There will be different numbers for every table. So this is what we're checking for, though. We want this consistency. That means that it's linear. So if I'm looking at this first function, I have 2 and 1, 3 and 5, 4 and 9, 5 and 13. So this is my x, this is my y. So I want to make sure for each time I move forward, I'm moving forward by the same amount. +1, +1, +1. Whoops. And sometimes, I will admit that I've seen it happen, is that instead of increasing by the same amount, sometimes they do increase by a different amount on the x column. I don't think they're going to do that necessarily for us yet, but I've seen it happen before in ALEKS. And we want to make sure that it's proportional. So on this side, it looks like we're going up by 4 each time. +4, I can write that. That's silliness. I don't know why I did such a small jump there, but same idea. So we are going up by the same amount. And if they were different amounts, what we would want to make sure is that our rise, which is 4, over our run is always the same. And in this case, it's 4 over 1, 4 over 1, 4 over 1. So if you had different numbers, put them in rise over run and make sure they don't reduce to the same number, because that's sometimes does happen. So in this case, that looks like we're good to go. They are linear. They have that consistency to them. So if we look at the next one, let's see, we have x, y. We have 5, 4, 9, 4, 13, 4, 17, 4. So now we're going up by 4 here each time. But on this side, we're going up by 0. There's no change. Remember, rise over run. So this is not undefined. This one is okay. What it means is this is a 0 slope or a flat line. So this one is still okay. It's still linear because we still have that consistent change on the x and the y's. All right, I'm going to, whoops, I meant to do that. I'm going to erase those. And so now I have -4, -3, 2, -2, -1, and -1, and -4. X and Y. All right, so now it looks like I'm adding 1 each time here. -4 to -3, that's 1. -3 to -2, and -2 to -1. So that's consistent for X. Now let's look at the Y. So we have -3 to -2, I added 1. -2 to -1, I added 1 again. But this guy, -1 to -4, well, that means I subtracted 3. I'm going to go backwards there from what I was in the other ones. So we were consistent here, and we are not consistent for the Y column, so this is not linear. All right, -2, -4, 1, -8, 4, -13, and 7, -20. So now we're going to do the same thing. We're going to just test. So -2 to 1, that means I'm adding 3. 1 to 4, I'm adding 3 again. And 4 to 7, I'm adding 3 again. So that's consistent. Yay. We wanted to see that consistency. Here, I'm going to subtract 4 because I'm going from negative to a even farther negative. This guy, I'm going to subtract 5 to get there, from -8 to -13. And then I'm going to subtract 7 to go from 13 to 20. So this is definitely not consistent. So we would say not linear. All right, perfect. All right, so we have a word problem here to think about. So Isabel has been withdrawing the same amount of money from her account every month. So we can think about that sentence before we even get too far. We have a person, we have a bank account, and she's withdrawing money. She's taking money out. So this is going to be a subtraction problem. From the table below, or the table below shows the amount of money in her account after different amounts of time. So 6 months, she had $640. After 8 months, she had $570. 10 months, she had $500. So we can definitely see this is going down as they add months to this. So we want to know how much money was in her bank account before Isabella started withdrawing money. So we want to first figure out, well, how much is she withdrawing each month? So we're going to go 640 minus the 570. I want to know how much is she withdrawing. In this case, I want to know what the change is here. So in this case, it's going to be 0, and let's see. I'd end up having to borrow, and that'd be 14, so that'd be 7. So she's withdrawing $70 there. And if I look 570 to 500, that makes sense. That's $70 less. And if we did that same thing here, we'd have 500 to 430, that's $70 less. So she's taking out $70 for each one of these jumps. But this isn't per month. This is every 2 months she's taking this out. So I want to say $70 per month. How much is that going to be if I do 70 over 2? Because this is my change in Y over my change in X. So this is going to be $35 per month. So she's taking out $35 every month. And we want to know what she started with at the beginning here. Not necessarily at 6 months. So I want to go back. And I want to add that back. So remember, we're starting the table at 640. But she's been withdrawing $35 for those 6 months. So she withdrew in month 5, 4, 3, 2, and 1. So that's 5 months we need to account for. So we're going to go plus, because we have to add it back. 35 times 5. This is the 5 months that she's been withdrawing $35, and we're putting it back in the account. We're kind of taking a step back in time here. So we're going to go 35 times 5, and we get 175, plus the 640 that we see the table starting on, but that's at the 6 month mark. So plus 640, and she had $815 to start with. We just had to kind of take a step back there, and you can even kind of use the table to step back and go, at 4 months, she would have had an extra $70. At 2 months, she would have had another $70 from there. So you could have taken your step backs that way too. So choose the statement that best describes how the time and the amount of money in her account are related, and then give the value requested. So as time increases, the amount of money in her account decreases. That's true, because as time goes on, she's taking more and more out. The second option is as time increases, the amount of money in her account increases. Well, that's not true, because she's withdrawing money. So I know it's this one. At what rate is the amount of money in her account decreasing? So they want to know how much is she taking out per month. Well, we already figured that out, right? It's $35 per month, because that's what we did up here. All right, so we're going to check this guy. And, what happened? Let's see. Oh, okay. So I forgot to include month 0 is what I did. So we should have actually multiplied by 6 here to get a little bit bigger number there, just because we wanted to include that actual 0 month. So it's 5, 4, 3, 2, 1, 0. So I should have multiplied by 6. That was just my oops there. Just to account for all of those months that have moved forward from the starting point. So we should have added 210, which would have gotten us 850 instead of 815. So I was starting at month 1 instead of month 0. So I just had to take a step back and think about it again and kind of go all the way back to the 0 month there. All right, we have one more of these problems. Okay, so we have Felipe is draining an aquarium. So again, we have a person, we have an aquarium, he's draining it. So I know it's going down. He's taking water out of the aquarium. The graph shows the amount of water in liters in the aquarium versus time in minutes. So here's the amount of water versus the time on the bottom. So I can see that this is dropping down. It's a negative slope. So answer the following questions. What is the amount of water in the aquarium at 0 minutes? So I have 0 minutes here, and I just want to go up to my graph and say, well, how much did we start with? So it looks like he started with 120. So 120 liters. Choose the statement that best describes how the time and amount of water are related, and then give the requested value, or the value requested. As time increases, the amount of water in the aquarium decreases. That does look true. As time is moving forward, the water is dropping lower and lower until it gets to 0 here. Or it increases. Well, we know it's not increasing. He's draining it, so it's decreasing. At what rate is it decreasing? So we need to look at this really quick. If we started with 120, and we can go down here to this second point here where it crosses. So after 1 minute, we have 84. So, oh, dang it. We started with 120. We went down to 84 after 1 minute. So we just want to subtract those two. That'll tell us how much he drained in that 1 minute. So he's draining 36 liters per minute. And this is down. It's decreasing by 36. So they don't necessarily want you to put negative 36. This is saying at what rate is it decreasing? 36 liters per minute. We're already using the word decreasing in here. So we don't have to type in negative. We can just say it's 36 liters per minute like that. When you are actually typing in your slope and stuff, when we start doing that, you will need to indicate whether or not it's negative or positive. But in this case, we have some wording that kind of helps indicate that for us. All right, well, that was section 3, and I will see you in section 4.